Hi, it's great to be here. In a minute, I'll introduce myself, but let us start with the challenge. We have quite a big challenge here. Accessibility of 3D and immersive content via voice interaction. Can we have a unified approach to take 3D content in general and even more challenging immersive content like virtual reality or augmented reality or even real life and make it accessible for people with different kinds of disabilities via voice interaction or other methods? And I think there might be an approach to do that in a unified manner, and I think we might have a way. My name is Zohar Gan, and I have been thinking and working on the main idea of this presentation for many years. I'm a solution architect and software developer, in addition to a full-time job doing independent accessibility research for many years as a social impact project. And my research can be found on the MIT licensed GitHub repository Semantic XR, which is also linked from the talk's description on the workshop agenda webpage. So the roadmap for this presentation journey is the idea, the challenge, and the opportunity. We'll talk about the specific details. We'll talk about stakeholder that we were asked to identify, standardization. We'll see a quick demo, and we'll finalize with the call for action. So the opportunity. I think that having a standardized way to semantically describe a 3D scene and knowing where to find this semantic media description will open up a very large number of opportunities to have 3D and immersive content accessible for many people with disabilities. So let's revisit the challenge. So let's simplify and let's take just a very simple example of names and locations of objects or people in the scene, 3D scene. So this is universal also to all kind of experiences. And if we take the name and the location and make them accessible and make them usable for accessibility solutions from the 3D experience, then the accessibility solution like screen reader can, for example, provide ways to do spatial audio for the different elements in the scene. Or, for example, do list navigation using a screen reader. So, or ask questions regarding where is the chair which is closest to me? Where is the exit sign? How many people in the room? Enabling this will open up a lot of opportunities and also there are also, of course, other fields, like not only name and location, just for simplification. And so this is a specific semantic 3D data model, which have names and location, but also many other fields. And it's not I don't say that this is the perfect solution. We're not looking here for the perfect solution. We're making progress, but it supports a lot of. It was built in order to support many of the accessibility solutions that are available in the market and in the academic research. So was the intention to enable a lot of accessibility solutions. And what makes me think that this is actually can be useful in practice is that it was tested in different proof of concept along the years, for example, in different scenarios and different technologies, like game engine, like 3D experience in a game engine, Unreal Engine, or a video of the 3D experience, or a 3D experience built in JavaScript library, 3JS, which we'll see today, 2D experience, or even a real-life video stream using AI. This was in April 2018, before the LLMs, etc., but was able to do that. So let's look at the idea in more details. So how does it work? So the 3D content accessibility flow. We have the 3D content creator, and the 3D content creator has a lot of information about their creation, about the 3D experience that they create. So if they have a car, for example, in their experience, they tag it, they put a tag on the car which says a car. And then it goes to the second step, the game engine, or they usually work in using a game engine or a JavaScript library, a 3D JavaScript library in a browser. So these entities, like a game engine, knows Unity or Unreal Engine, knows the exact location of entities. So it looks for the tags, it looks for the objects, it gets the tags, the name, and it knows the location. This 3D content creator doesn't need to specify that. And there are a lot of information that a game engine or a 3D library knows. So there is a generic semantic XR generator, which generates this semantic XR document, the metadata, the 3D semantic data model, and provide it to the accessibility solution along with the media, whether it's video, image, or 3D experience. And then it can be made accessible, like we talked before, to people with disability, like a screen reader that scans H1, H2, etc. Then it can scan and provide spatial audio for the names and locations or for the location of the cards, etc. So this is the flow from the 3D creator until the people with disabilities. And in contrast with AI that interprets the content according to their training, here we preserve the 3D content creator original intent, which I think is good and also somehow relates to what was mentioned yesterday in Sarah Wood's presentation regarding preserving the preference for pronunciation of how user wants to pronounce their voice. So we care about the intent of the creator. And there are also an AI discussion is a different discussion. Maybe we can do it afterwards or in the breakout session. So stakeholders. So there are people with disabilities first and foremost, and let's go over that. So the W3C XR accessibility user requirements specify a lot of user needs, and I will focus just on two to demonstrate how it applies. So voice commands. User need is a user with limited mobility may want to be able to use voice commands within the immersive environment to navigate, interact, and communicate with others. So we will see voice interaction with the 3D experience, and we will focus on the perception, not the interaction. Interaction and action is also something which also a different topic which we might discuss, WebMCP or things like that, but we will talk about perception of the 3D experience. We'll see that, hear that more accurately. And immersive semantic and customization is another area. The user need is a user of assistive technology who wants to navigate, identify locations, objects, and interact within an immersive environment. So for example, requirement 1D allow the user to filter or sort objects and content. So we will see that how we sort the names and locations or other things in the demo, and allow the user to query objects and content for more details like instructions, descriptions, stuff like that, which is part of the semantic data model. Yeah, so it's quite natural to do that. For a complete analysis of the W3CXR accessibility user requirements, you can check out the repository. There is a special page which goes on the entire list of user needs and specify how they apply to this. Not all of them can be solved, of course, but you might be surprised at how many can be, we can make progress on those. So a few more stakeholders, the 3D content creators, two things. They tag their content. So the generic semantic XR generator can use it for making the semantic XR available. And in addition, they need to also check their experience test it with people with disabilities to make sure that the solutions are applicable and they are configured correctly and they're working correctly and as requested. Assistive technology developers, they are the ones that use this semantic XR and make the things accessible. And finally, the standards organizations like the W3C. And things that I suggest the candidate for standardization are the semantic 3D data model itself. So what is mandatory, what is optional, and number two is integration point. For example, in a web content, image, video, and canvas would be really awesome to get some integration points, and there are some ideas how to do it. It's open for, of course, big discussion. And finally, maybe also spatial speech. Maybe it's my fault. I couldn't find an easy way to put the speech synthesis into the web audio specializations. But if spatial speech is not yet standardized, that it would be nice for spatial audio and immersive environments. So let's just switch over to the demo. So It's a live demo. So here we see a title demo of 3D accessibility semantic XR. There are the upper part of the page which says choose the 3D experience, where you can choose an experience, and the lower part which says choose an accessibility solution. And you can mix and match because the only interface between the two is the semantic XR. Let's start. Experience conference room. Experience conference room.
Conference room.
Solution horizontal scan.
Horizontal scan, left to right. Presentation screen, conference speaker, John, professional podium, conference room floor, back wall, center, Thomas, Michael, Emma, Sarah, right wall.
This is a Canvas 3JS application. We can move around, and let's switch to another experience. Experience cabin scene.
Cabin scene.
Solution collision prediction.
Collision prediction. Cabin door is 6 meters ahead.
Now we'll move backwards. Solution collision prediction.
Collision prediction. Cabin door is 14 meters ahead.
Okay, great. Now let's move around, and let's say voice speak faster. Voice talk faster.
Voice speed increased to 4.0.
Solution instructions.
Instructions. Explore the woodland scene using WASD keys for movement and arrow keys for looking around. Walk around the cabin to see it from different angles.
And finally, let's go back to the experience conference room.
Conference room.
Solution markers.
Markers.
And now this is something that a feature that updates continuously. So we have text labels on top of the entities, entire entities in the conference room. And this updates wherever we move, it shows them on the rotation and orientation and the location on top of the entities. So this can be helpful for people with low vision to provide more information. This can be helpful for people with color blindness. So we can have, instead of text, we can have shapes like SVGs or other things that can enable to differentiate between entities using shapes and not only colors. And also show numbers feature for people with physical disabilities. So every entity has a unique number that can be referenced and provide more details about it. Okay, so this is the demo. And just to close the presentation with the call for action. So the opportunity that we discussed is having a standardized ways to semantically describe a 3D scene and knowing where to find the semantic media description will open up a very large number of opportunities to have 3D and immersive content accessible for many people with disabilities. So if this resonates with you, if you have ways to improve it, if you have ideas, if you have feedback, if you have some expertise which is helpful for that, this would be great if you can join the new community group. I proposed, and it was created 2 days ago, the Semantic 3D Content Accessibility Community Group. And it would be great to have you have a seat at the table and as a community make semantic 3D content accessibility a reality, an accessible reality. Thank you.